Today we're going to be looking at how to graph uh, another form of rational functions. So this will be rational functions in the form of y equals a, that's a constant, over x minus h plus k. A, h, and k are constants. First we find the vertical asymptote, which is equal to the h value. Okay, that's going to be the undefined restricted value that makes the denominator equal to 0. That will be the vertical asymptote, a dashed line up and down. Horizontal asymptote will be equal to the k value. Okay. Find the coordinate of the y-intercept. So y-intercept means substituting 0 for x. Find the coordinate of the x-intercept, which is 0 for y. And then we're going to make a table of values, 3x values smaller than the vertical asymptote, and 3x values larger than the vertical asymptote, and then identify the domain and range. So first we'll look at the first problem. Y is equal to 2 over x minus 4 plus 2. Okay, in this case the a is 2. So if we're looking at the form, a is 2, h is 4, and k is 2. Vertical asymptote is equal to the h value. So it's going to be x is equal to 4. It's going to be a dotted line up and down at 4. The horizontal asymptote is equal to the k value. So that's going to be y is equal to 2, the k value. It's going to be a horizontal line that goes through 2 on the y-axis. The x-intercept, so we will substitute in 0 for y. So if we do that, go to a blank page, we would have 0 equals 2 over x minus 4 plus 2. And we would have to solve this for the corresponding x value. This is easy enough. We would subtract 2. And we get negative 2 is equal to 2 over x minus 4. And then we can cross multiply here so that we get negative 2 times x minus 4 is equal to 2. And divide by negative 2. So we get x minus 4 is equal to negative 1. Add 4, x is equal to 3. So that's the x-coordinate of our x-intercept. So we have 3, 0. We can put that as a point. That's right here. Our y-intercept, so we can plug in 0 for x to do this one. This one's going to be a little bit easier. So if we plug in 0 for x instead, we get y is equal to 2 over 0 minus 4 plus 2. So that's 2 over negative 4 plus 2. That's negative 1/2, which is negative 0.5 plus 2, which is 1.5. So we get 0, 1.5. So that's going to be like right here. Okay, so for our table, our horizontal asymptote will be right here, 4. Okay, it doesn't have an output because it's on the dotted line. But we want 3 to the left and 3 to the right of that. So 3, 2, and 1 are to the left of that. 5, 6, and 7 are to the right of that. We're going to have to plug all of these values in to find all of our points. Okay, so we have our equation, y is equal to 2 over x minus 4 plus 2. And we're first going to plug in 1. So x equals 1. We got y is equal to 2 over 1 minus 4 plus 2. So that's 2 over negative 3. So negative 2/3 plus 2 is 1 1/3, which is 1.3 repeating about. So since I'm going to graph it, I do want it graphable. So 1.3. So 1 comma 1.3, which is like right here. Next I'll plug in 2. So y equals 2 over 2 minus, wait a minute. I already have the value of 2. Don't I? No, I don't. Okay. So plug in 2. We got 2 over negative 2 plus 2. Negative 1 plus 2, which is just 1. So my next point is 2, 1, which is right here. And then I already have 3. It's 3, 0. I already have that point there. So kind of seeing what the left side looks like. Let's jump to the right side. So I'm going to plug in 5. So y equals 2 over 5 minus 4 plus 2. So 2 over 1 plus 2, which is 4. So 5, 4, which is right here. Plug in 6. So y equals 2 over 6 minus 4 plus 2. That's 2 over 2 plus 2. 1 plus 2, which is 3. So 6, 3. And then plug in 7, kind of running out of room here. Y equals 2 over 7 minus 4 plus 2. 2 over 3 plus 2. So that's like 2.6. Or 2.7. Let's do 2.7. So right here about, okay, so now I can connect these points to make my graph. Should get close to the asymptote just like before. Over here it's going to curve and get close to the asymptote as well. Not the prettiest, okay, that I kind of did a bad job here. Should be a smooth curve like this, okay. Over here, same idea, curve, get close to the asymptote, curve, get close to the asymptote. Now let's compare this graph to what Desmos would give us if we graphed it on a graphing calculator. Okay, so y is equal to 2 over x minus 2 plus 2. That's what I have, right? 2, sorry, x minus 4. Okay, and we can see our graph is pretty darn close, okay? The curvature is a little off, but it's pretty darn close. The asymptotes are for sure in the right spots. The intercepts, 3, 0, 0, 1.5, those are in the right spots. So everything looks pretty good. The domain. So the domain is everything except for 4. Okay, 4 is the only value not allowed in the domain. So we'd say negative infinity to 4, union 4 to infinity. The range is everything except for 2. Okay, so we'd say negative infinity to 2, union 2 to infinity. All right, let's look at this next one. So we have A is negative 3, H is negative 1, K is negative 4. Vertical asymptote is equal to H, so that's X equals negative 1. So negative 1, that is right here. K, so the horizontal asymptote is K, Y is equal to negative 4. The x-intercept, we would have to plug in y equals 0 to find this. So if we plug it in here, we get 0 is equal to negative 3 over x plus 1 minus 4. So we solve this, we add 4. So 4 is equal to negative 3 over x plus 1. Multiply both sides by x plus 1. So we get 4 times x plus 1 equals negative 3. Divide by 4. We get x plus 1 equals negative 3 over 4. Subtract 1, x equals negative 1.75. Okay, so our x-intercept, negative 1.75, comma 0. So that's like right here. Y-intercept, plug in 0 for x. So our equation becomes y is equal to negative 3, 0 plus 1, minus 4. So that's negative 3 over 1 minus 4, negative 3 minus 4, which is negative 7. So 0, comma, negative 7, which is down here. Okay, so in the middle of my table will be the vertical asymptote negative 1, which doesn't have a value. To the left of that, negative 2, negative 3, and negative 4. To the right of that is 0, 1, and 2, and I need to find the values for all of these in the table. So I need to start plugging into the equation. Y is equal to negative 3 over x plus 1 minus 4. So I'll start with negative 4. So y equals negative 3 over negative 4 plus 1 minus 4. Negative 3 over negative 3 minus 4 is 1 minus 4, which is negative 3. So negative 4, negative 3 is right here. Next, we'll plug in negative 3. So y equals negative 3 over negative 3 plus 1 minus 4. Negative 3 over negative 2 minus 4. So that's 1.5 minus 4. Sorry, 1.5 minus 4, because that's 3 halves, which is 1.5. Which is negative 2.5. So negative 3, negative 2.5, which is right here. And then negative 2. So y equals negative 3 over negative 2 plus 1 minus 4. Negative 3 over negative 1 minus 4, which is 3 minus 4, which is negative 1. So negative 2, negative 1 right here. All right, 0. Wait, I already have that value actually. 0 for x, yeah, it gives us -7. I already have that right here. A 1, so y equals -3 over 1 plus 1 minus 4. -3 over 2 minus 4. -1.5 minus 4, which is -5.5. So 1, -5.5 is right here, and then we'll plug in 2. So y equals -3 over 2 plus 1 minus 4. -3 over 3 minus 4. -1 minus 4, which is -5. So 2, -5, like right here. I can connect these to make curves. So this curve, like this, gets close to the asymptote. Over here gets close to the asymptote. Over here gets close to the asymptote. And down here gets close to the asymptote. The domain is everything except for -1 here. So -infinity to -1, not including -1, union -1 to infinity, also not including -1. The range is everything except for -4 here, so -infinity to -4, not including -4, union -4 to infinity. And that is our range. All right, pretty nice looking graph. All right, here are the homework problems.